Hi there, Gary here from the Australian Cleaning and Restoration Academy. Well, we're here today to talk about timber moisture in a piece of timber here. This is a piece of particle board. Now, this is part 3. We're going to be talking about an equivalent reading. What is an equivalent reading? Well, some people say it might be moisture content, and I still get a little bit confused. Now, let me run through this to try to find out. So, an equivalent reading for me is this. Let me talk about, before I do this, let me show you our understanding here. Let's go back to our meter here, and we're going to talk about why the surface temperature is important. Okay, so what we're going to do is hammer probe into our piece of particle board. I think I've made some holes here to make it a little bit easier, so I'm not banging away here. Make sure my pins are tight. Okay, now we're in. Now we've connected up to our gun CH17 moisture meter. I like to use a hammer probe where I can plug in my cable, because the cable is the first thing to fail on a moisture meter to protect the actual hammer probe. Now, what I've got here is I've got it set on 20 degrees and I've set on Douglas fir. Now we know this is not Douglas fir. So let's take a reading. It's saying 9.4%. This is 9.4 wood moisture equivalent percent, or 9.4% wood moisture equivalent. It's an equivalent reading, okay? Now this is set on 20 degrees. You watch this. If I go in there and change the temperature, let's say you go there and you're doing some heat drying or something, and let's say the temperature of the timber is 50 degrees. Now, if I do this, look at our reading, we're at 6.5%. So every time, on average, I go from 20, because most meters are set on 20 degrees. If I go to 30 degrees, some meters you cannot change. So if I go to 30 degrees, it might read 1.5% drier. 40 degrees can read up to 3% drier. 50 degrees can read up to 4.5% drier. So this is really important to make sure you look at surface temperature and put it in there to your meter. Now, if you can't, you're not going to be accurate. Now, if I go back down here and I go to 0 degrees, because let's say it's really cold, changed it to 0 degrees, okay? So right now we're at 11.5%. So what happens is it can go up if I go down to 10 degrees, it can read higher, 1.5% higher on average, and 0 degrees can read up to 3% higher on average. So at the end of the day, I have to go in and set the temperature. And remember, we went through on part 1 of the video series about taking surface temperature. So this is really, really important. Okay, so now when I'm doing an equivalent here, so let's take it back to 20 degrees. Okay, so we're back at 20 degrees. And remember, we took a reading before. We're at 9.4, 9.3%. So let's go from here. We'll go to the affected area. Sorry about the noise. Okay, now we're going to the affected area and we'll take a reading. It's saying 16.9%. Now, is that 16.9%? Well, no, it's not, because it's set on Douglas fir. Okay, so it's really important that you look at that. So it's not 16.9%, it's 16.9% wood moisture equivalent. I've gone to the unaffected area reading 9.4, gone to the affected area reading 16.9, so we know we're elevated over 7% elevation. Okay, so we know that we have to dry this area. Now, if I get a protimeter here with our pins, the benefit of doing my insulated pins here, I can check tips only, so I can check the top of the board, the middle of the board, and the bottom of the board. Where if I've got 2 little pins here, I'm only checking the surface, which can be not good enough. I want to know what the middle and the bottom of the board is reading. So here we go. Here we've set it on WME. See if I can push hard enough. Sometimes I can. No, it's below 6%. Over here, we're at 20%. So which one of those is correct? This one's set on 20 degrees. We know it's about 20 degrees anyway, but at the end of the day, if this was 30 degrees, it'd be actually more out. If it was 40 degrees, it'd be even more out. So it's really important to understand that. Now, what specific gravity, what timber is that set on? If that's set on Douglas fir, this is not Douglas fir. So that is when I'm talking about an equivalent, I have to go to an unaffected area versus an affected area, but I'm getting a percentage more because it's a timber meter, where this might not be a timber meter, okay? And the back of this might not be a timber meter, okay? So at the end of the day, you need to look at, when you look at relative scale and equivalent scale, there is a difference, okay? So I hope this helps. Stay tuned for part 4 when we talk about absolute value. Thanks so much for watching.